Yeah, I had So I guess we'll start. My name is Vicki Swear, and I'm a member here of the congregation. My husband is somewhere, he's going to sit here. And our son Zeke is the striped shirt kid that was running all over the church like a crazy chicken. That's our kid. That's Zeke. So we were members here earlier this year. I think we became official members. We've been coming to the church for a while, but then I decided we should just do the official paperwork and become members. I've been a Presbyterian since I was like a teenager. My husband was a Catholic, so I converted him over to becoming a Presbyterian when we got married. Yeah. So, yay. So we came from Omaha to Sioux Falls in like 2017 so I could start my job at Sanford Research. I work as a staff scientist there, and our lab, the Weimer lab, so Jill Weimer is the PI or the principal investigator of the lab. She does a lot of stuff, but so when you have like a lab, I'm sure you all know, but when you have a lab, you have like the person who writes the grants and like oversees everybody, and our lab is really big, so you have a bunch of maybe grad students and technicians, and every now and then you'll get like a postdoc or some type of scientist that comes in and helps do research. So in Sanford Research, there is multiple different groups, and one of the groups that Jill oversees is rare pediatric diseases. So I'm going to talk today about what research we do and rare pediatric diseases overall. So that's just kind of my opening spiel. Yes. Okay, sorry. All right. So in my title, I kind of go over the ABCs of rare disease. So I was like, that's a good title, but what does it really mean? So I'm going to talk about advocacy, or getting the word out about rare diseases and how we can maybe get funding. And I'll talk about the biology of rare disease, kind of get a high overview. And then kind of the community of people working together to feel like a close relationship so you don't feel like you're alone. But it's not going to be in that order. I'm going to skip around, but you'll know what the acronym means now. So rare diseases. When you think of rare, show of hands, or you can just shout it out, what do you think of when you hear rare human diseases? Unusual. That's a good one. 1 in a million. That's awesome. Yes, I always think it's you're never going to find anybody with that, right? It's super, super rare. Anybody else? Exactly, that's a very good. Expensive to treat, right? Maybe your insurance won't cover that because you have something that nobody's ever heard of. So rare diseases actually affect more people than cancer, AIDS, and combined. And if you also look at diabetes and heart disease. So it's kind of more than we associate. Everybody knows about cancer, everybody knows about heart disease, it's pretty prevalent, it's, in the media, you probably know somebody that has this. But if you combine all the rare diseases together, they can actually be more than what you know about cancer and heart disease. And if we look down here, the sad thing about this is that people can go undiagnosed. So they'll have something unusual, they aren't able to walk well, or they have some cognitive decline. They're not able to do like basic, thinking processes. So they'll go in and they'll talk to their physician, or in our case, it's children. So their parents will go in and say, my kid is experiencing this. I don't know what's going on. And the physician will be like, I don't know what's going on either. So a lot of these people go undiagnosed. 36% are undiagnosed for over 1 year. So that's pretty scary. You don't know what's going on with your kid. 14% are undiagnosed for over 6 years. So that's 6 years you don't know what's going on. It's kind of even worse. 28% can't attend school, and 21% are less than 16 years old. And the diseases that I'll talk about today really affect kids as early as like 18 months. The percentage of rare disease, so up here in the upper corner, that have FDA-approved treatments, there's only like 5%. It takes a long time to get a clinical trial to get to the stage where people can actually take it. So if there's only 5% treatments out there, that just getting the word out that there's not enough treatments, how can we get more treatments to people, and people being aware of what needs to be done? And 95% have no drug or therapy. So you're out of luck. I'm sorry you have this, but good luck. And half of those with rare disease don't have a disease-specific foundation. So they don't have like a community to reach out to. Somebody to say, hey, I have this disease, who do I talk to? And they don't really have anybody to talk to. So there's a lot of sad things associated with rare diseases. Kind of my job, or I feel like it's my job, to get the word out so people are aware, so maybe we can prevent some of these things, or at least maybe reduce them. All over the world, there's 300 million people worldwide that have rare diseases. So it's quite a bit. The nice thing about that, maybe not the nice thing about that, but there's a rare disease day that people can come together and advocate for rare diseases. So there's one specific day in February. Last year was February 28th. This year it's going to be February 29th. So 2024, it's going to be February 29th. So keep that in mind. They have a lot of things going on. Even in Sioux Falls, there's stuff that's going on. So on that day, they light up the falls. So Sanford Research has, since we're researching rare diseases, we want to bring that out into the public. So they color the falls. Anybody seen this in the last couple of years? No? Well, on February 29th, go out and check it out. They light up the bridge too with the rare disease colors. And there's cupcakes. So, yeah, I know. The Oh My Cupcakes, I think it's Oh My Cupcakes, they have a cupcake that will support, so a percentage of those profits go to rare disease research. It probably helps to go for different foundations or back to Sanford Research, but they're really good. I mean, I'm trying to train to be a dietitian now, so it must be a really good cupcake if I'm, maybe just share it with a friend though, but it's very good. So look for that next year. So within Sanford Research, this CORDS program is helping to kind of coordinate advocacy and community and participants all together so that people can have a sense of community. And this is really helpful for researchers too, because then you kind of have this patient registry, so people that you could contact if those people want to be contacted to help you with your research. And those people actually can work with others, so they know that, hey, I'm in South Dakota and I have this, but somebody over in Iowa has this as well. Maybe we can form our own community, which I think is a great way for people to get together. And there's also a symposium that goes on. It's in the spring, I think, at Sanford, that they'll have the usual scientific meeting where people will get up and talk, and they'll have posters. And then the next day, they'll have patients come in, or participants of the registry will come in, so they can all gather together. They can hear the research if they want to, or they can just gather together and talk and form a community, which I think is really cool. When you do research, I've been doing research for a long time. I started getting into more clinical research when I was in Omaha and then when we moved to Sioux Falls. So you don't really think about people. Maybe you think about the experiment. I'm working on the lab bench, I'm doing my stuff. You don't think about the people, you just think about, I want to get results, I want to get it done, I want to help people, but you don't like see a face. So this is nice because you can see individuals that have the disease. So maybe you can picture somebody in your head, I'm trying to help this person. It becomes more personalized. It's not just, as a scientist, you think rationally, you try not to be too emotional, but I think it's good to have a little bit of that emotionality in there to drive you to try and do better on your research. So they reached out to 100 different partners. They have 18,000 participants. It's just growing and growing and growing. I can give these slides to anybody who wants, but you can follow them on Facebook or Instagram if you want to learn more about cords. Ben is the guy that oversees this, and he always is very passionate about getting people together, and we'll have people come in the lab and watch us do stuff in the lab, and it's just nice to kind of put the participants together with the researchers, and this is a really good registry for that. So now we kind of have an idea of what's out there. How does rare diseases associate with other, commonly known diseases? So this might be a little fuzzy, but what does the red one say? Can you read that?
31 out of 100 people live with cardiovascular disease.
Right, so that's the highest right now, the highest prevalence of this particular slide. But compare that to how many people live with diabetes? What do you see there? 5 out of 100? How many people live with cancer? How many people live with rare diseases? So the prevalence of rare diseases in our population, I think this might just be the United States, is the same as the prevalence of cancer, same as the prevalence of diabetes. But you hear about diabetes, you hear about cancer, all unfortunate things, but you hear more about that in the media than you do rare diseases. But they have the same prevalence. Just keep that in mind. So then the question becomes, are rare diseases really rare? If we compare it to heart disease, maybe, but if we're comparing it to cancer or diabetes, it's not necessarily rare. Maybe it's just unknown. I would say unknown is a pretty good word to describe that. What are the rare diseases that we work on in the Weimer Lab? Batten's disease is one of the most common ones that we've worked on. Jill has been working on this for most of her career. Batten's disease is a rare pediatric disease, and all the stuff that we work on are like neurological diseases. So there's quite a few. So it's a big family. They all have like a commonality where lipofuscinosis, is a hard word to say, accumulates in neurons. And that causes the decline of the neurons, the decline of mental health, decline of motor health. They all have that same thing. So there's 10 different variants, there's quite a few, 13 different genes that are responsible for Batten disease as a whole. And rare disease is usually defined as 1 in 100,000. So this kind of is in that rare disease category, 1 in 100,000 live births. But this really, collectively, all the Batten's disease together is the most common of all pediatric neurological diseases. The sad thing is that there's no cure, and if your child has it, unless you can give therapies that, prolong their life or improve their quality of life, there's no cure. So that child is not going to survive. And it's sad because all these things that happen before the child dies, first, in some varieties, they lose their vision first. And if you think about a little kid, so usually this happens, like CLN3 is the one that we study very commonly. They'll start to lose their vision at like 6 or 8 years of age. And think of yourself when you were 6 or 8, you hung out with your friends, you rode your bikes, you went swimming. You can't do any of that when you lose your sight. And then you kind of feel ostracized. Nobody wants to play with me because I can't see. So what can we do to sort of prevent that from happening? I mean, it'll eventually happen, but what can we do to, slow the progression down? And then after blindness, there's motor abnormalities. The kids aren't able to walk anymore. They'll start, not being able to walk well, and then they will end up not being able to walk at all. Seizures are really common. You see neuron loss, so the cells in the brain, they start to die. There's cognitive issues like dementia, sleep disorders, and eventually premature death. So it's super sad. What can we do to help these kids? And this is going to be something that's a mutation. So it's going to be from your parents. It's not something that's acquired from the environment or like cancer, that's a genetic too, but there's things you can do to, promote cancer in your life. This is something you're going to get from your father and your mother. And, it's 25% possibility that a child will get Batten's disease if their father and mother have it. So that's the only way that a person can get Batten's disease. I think Batten's disease was first diagnosed in like the late 1800s, but I think it's always been called Batten's disease, but I think more and more mutation or genes were found. So I think like the first one might have been CLN3 because it's more prevalent in the population, but now they've identified like 1 through 14. So as more and more people show these symptoms and they do like genetic testing on them, they can find that there's more mutations. Yeah. So this is the most biological slide that I'll show. There's a lot of, this is just showing you all the different gene variants of Batten's disease, and the nucleus is the big blue thing. The important thing here is to show, I don't know if my little arrow works. Can you see my little arrow? Yeah, you could. That functional component. So like CLN1 and CLN2 are both like enzyme driven, but like CLN3 sits on the membrane of the lysosome, and like CLN4, CLN7, they all have different like functional purposes. And some we don't actually know what they do. CLN3, which is that green looking thing that sits on top of here, there's a lot of work now just trying to figure out what it does. So if we don't know what it does, how can we treat it, right? Once we figure that out, then we can probably do more effective therapies. And what we do in the lab, we do a lot of work with CLN3 and CLN2. CLN2 is late infantile Batten's disease, so kids will pick this up 18 months, 20 months of age, and they'll probably die around their teenager maybe. CLN3, they're all kind of, some of